Have you ever wondered the reason to the sudden changes in the ocean? The rising ocean level and the increase of endangered species? In this documentary, we'll enlist some of the reasons to this phenomenon, known as climate change, and how it affects our ocean.
But what is climate change? It's a change in the pattern of weather and related changes in oceans, land surface, and ice sheets, occurring over time scales of decades or longer. The ocean is a continuous body of salt water that covers more than 70% of the Earth's surface.
Ocean waters are warming, which has consequences on the ocean's properties and dynamics, on its exchanges with the atmosphere and on the habitats of marine ecosystems. Measurements from tide gauges and satellites have shown that the sea is rising globally at an average rate of about 1.7 millimeters per year since the beginning of the 20th century, a direct consequence of human-driven global warming.
The ocean absorbs, stores, and transports heat from the sun through its flow motion, affecting atmospheric temperatures and circulation around the world.
Study of properties and movement of seawater show that the Gulf waters were warmer than any time on record according to the National Center for Atmospheric Research, and it shows also that it can cause devastating flooding. The volume of rain over land corresponds to the amount of water evaporated from the unusually warm ocean. Climate change continues to hit the ocean. We can expect more supercharged storms. The ocean absorbs a quarter of CO2 produced by human activities, causing a chemical modification of seawater that results in ocean acidification. Ocean acidity has increased by 30% in 250 years.
Open ocean deoxygenation, warming, and ocean acidification are all driven by increased atmospheric carbon dioxide.
Greenhouse carbon dioxide is turning ocean waters acidic, and an influx of fresh water from melting glaciers threatens to alter the weather driving currents, raise atmospheric carbon dioxide levels from 218 parts per million to 400 parts per million in the last 150 years. Life in the ocean consumes and releases large quantities of carbon dioxide. Across the Earth's oceans, tiny marine plants called phytoplankton use chlorophyll to capture sunlight during photosynthesis and use the energy to produce sugars. Phytoplankton are the basis of the ocean food web, and they play a significant role in Earth's climate, since they draw down carbon dioxide, a greenhouse gas, at the same time rate as land plants. About half of the oxygen we breathe arises from photosynthesis in the ocean. Temperature of the sea surface sets the temperature at the base of the atmosphere and determines evaporation and hence the Earth's water cycle. The oceans dominate more than 90% heat gain in the climate system. In other words, as the Earth receives more heat than is radiated into space, nearly all of the excess heat is stored in the ocean. Warming of Earth's climate has caused some snow and ice to melt. The warming also has caused oceans to rise, and it has changed the timing of when certain plants grow.
Changes in the physico-chemical characteristics of seawater affect the metabolism of individuals, the life cycles of species, relationships between predators and prey, and the modification of habitats. climate change is affecting the productivity of marine ecosystems and impacting fisheries, while the demand for fish for human consumption is increasing. Fish is the main source of animal protein for 1 billion people and is one of the renewable resources most transacted in the world. The deep ocean represents over 98% of marine waters in volume. Even on the abyssal plains, variations in abundance of key species have been attributed to changes in the photosynthetic productivity at the surface of the ocean. Biodiversity and productivity hotspots of the deep seafloor could be particularly vulnerable to the already observable changes at the great depths, such as local regions warming deep water, acidification and deoxygenation, and modifications of the circulation of water masses.
By satellite, scientists calculate maps of the sea surface height and changes in the height due to tides, changing currents, heat stored in the ocean, and amount of water in the ocean. By mapping the topography of the ocean, we can determine the speed and direction of ocean currents. Just as wind blows around high and low pressure centers in the atmosphere, water flows around the high and lows of the ocean surface.
There are lots of factors that increase climate change and how it plays out in the ocean's future that we won't be able to talk about in this short documentary. I hope this video brings you helpful information referring to what is happening right now in our ocean. Thanks for watching.